Okay, it's proof time. So we're going to go ahead and look at what we should do for this proof. So I'm going to get some highlighters and fun stuff to work with. Let's check it out. Always, always, always start with your given. You don't need to be creative with your given. You just write it as is. And before you do anything else, you definitely want to mark your given because the visual is so helpful in figuring out what's going on. And of course, we have our given and we have our given. We then look here and we say, well, we're trying to prove that these two sides are equal to each other. The only way that we can prove that two sides are equal to each other is to prove first that the triangles are congruent to each other. So hopefully we have enough information. We look to see how we might use that. That's going to be a side, so awesome. I've got a side. I don't have any other sides or angles yet, but ooh, look at that. We've got reflexive. So we're going to say BD is equal to BD. Reflexive. I'm going to mark it and indicate that that's another side that I'm going to be using. This is not a side of equal length, and I've already used that. But even if that was all I knew, I wouldn't know that these were the same length. What I do know is they're going in the same direction, which gives me parallel lines. And we talked about this in class, but if you draw a little Z with the two parallel lines that is cut by the transversal, what you end up getting is these little dudes here and here are the alternate interior angles. And since they are parallel, those alternate interior angles are equal to each other. Now, I can't just say B is equal to D. Wow, I'm struggling with that. I can't just say B is equal to D because there's lots of stuff going on here. If I had A and C, I could say those, but here we have some ambiguity there. So those guys are equal, and the reason is parallel lines give us these. So parallel lines give us alternate interior angles are congruent to each other. So now I have an angle. So looking back at my picture, the angle is in between the two sides. The angle is in between the two sides. So I have the angle is in between the two sides. I've got my side and my angle coming in because I need to make sure that if this is my reason, I'm showing which ones I'm using. And I would say triangle A, there's lots of ways that you can write this. The thing you need to make sure of is that wherever A is for second or third, so also is C. And that wherever B is, so also is D. Now that my triangles are congruent to each other, that means all of the parts are as well. So that means that BC is congruent to AD because congruent triangles give me congruent parts. All right, let's look at number 2. 2, we have some different things going on. We've got our 2 sets of parallel lines this time. So we're going to mark them. And actually, before I mark anything else, I want to get the angles that are equal because of that. So I've got these dudes. Again, you can't just say A is equal to C. You need to be more specific because there are lots of stuff going on there. So BAC equals ACD, whoops, angle. And the reason is parallel lines imply alternate interior angles are equal to each other. Then we've got these guys are parallel. So we're going to mark those. And that one gives you these little fellas that are in the corners of that Z. So I've got angle, again, you can't say C and A because then I'd have to be saying the same thing, C and A and C and A. I've got to be more specific. BCA and CAD. And the reason is, again, parallel lines imply alternate interior angles are equal to each other. So far I have an A and an A. I've got 2 parts here. And I need a side. I don't have a side yet, but if I look at this one, little reflexive will come to the rescue. AC, ooh, it's like I'm writing my initials, equals AC, and that is our reflexive. So this is our S that we're going to use. So I have enough information to prove congruent triangles. All three of them come together. I have two angles with a side in between it. So I have two angles with a side in between it. And I've got triangle ABC is congruent to triangle CDA. I have to think about that. And I want to use my angles that are equal. So angle B is equal to angle D because the triangles, congruent triangles imply congruent parts. Now, that's one option. In this particular one, I didn't mean for it to happen, but there was another option that we could have done. We could have done here, where we had angle, angle, and I could have said that the two triangles were similar, and then the third angle is equal because similar triangles give me congruent angles. I also can go here and say that the third angle is equal to each other because of triangles equal 180, because if these are equal and those are equal, then the third set has to be equal to each other as well. So we do have a couple options on this particular one. This is just go, 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 go. Don't really think about it. Don't think about other options. Just kind of into the format. All right, here is our last one, number 3. We've got our givens. So again, you just always start off with your givens. You just write them as is. Don't be creative. Don't go all crazy. And then I mark them. And I use them. So here I've got options. I have this transversal, which would give me A and D. Or I have this transversal, which would give me B and E. It makes no difference which one you use. Either one is fine. The reason is the same for either of them. Now, here you have an option. We need another angle. So far we have one angle on one side. We can't really get those sides. We just don't have any information. We don't know the bisecting or anything like that. But it looks like we have two options for angles. We could use this other set here. So from here, I would say that angle B is equal to angle E for the same reason. That would give me enough information. Or I could say vertical angles. Since we already have that, on this proof, we'll go ahead and write vertical angles just so that you can have that example. You cannot say C equals C. Why? Because that would be ambiguous. We don't know really what's going on there, so we have to be more specific. So ACB equals, DCE. And that is vertical angles are congruent to each other. And these facts here would give us two angles and the side not in between it. So this was an angle, and this was an angle, and this was a side. Lots of options. Triangle, if I said ABC, then A goes with D, so as long as the A and the D are in the same slot, everything's fine. B goes with E, and obviously C goes with C. And then from there, you would get congruent triangles give us congruent parts. Now, let's just look at option numero dos. If I didn't go with the vertical angles there, and I instead wanted to say that angle B is equal to angle E because of parallel lines, then going in here, I wouldn't have had that. I would have had this. So my reason would have changed. Oops, sorry, I'm covering that up. My reason would have changed to ASA. So you have options. You just need to make sure that these things are telling me what actually is happening around the board.